So once you have identified a topic of your interest, okay, with some vague picture, of course, what we will do next is to look for some keywords, okay, and search those keywords in some academic search engine, for example scholar.google.com, okay. Or another important aspect of designing this thesis is to identify one or several data sets that will be suitable for your topic of interest, okay. So first point is identify some keywords, okay, and Google them in some academic search engine. So what will it give? It will give you some related methods, models, related papers and related data sets, okay. Next very important part is to identify one or several data sets that we are going to use. So if you are very fortunate, you may be able to get some real world data, and you may even be able to collect those data yourself. And in some cases, if you do not have access to the real world data, or if we cannot even visit the field, we may have to depend on open data. But open data are also, there are lots of open data which we can think of using, and some of these data sets are benchmark data sets, in the sense that they are commonly used for testing models, testing methods, and have and several papers have already used those data sets for their experiments. So it is also acceptable to use those benchmark data sets, okay. So one way is that first identify what data sets are available that suits your need, okay. Then now the data that you have thought to use might require some good amount of pre-processing, depending upon what is the stage of the data. If it is just collected from a survey or from a ground, or then you may have to pre-process the data, and it might take significant time. So one point to remember here is that please realize that by pre-processing the data, you are only doing one part of the work, remaining bulk part is still left. The data is just an input to your thesis, to your dissertation. The remaining bigger part that is expected out of research is still to start, okay. So do not spend too much time only on data cleaning and data preparation. Yes, it is important, but that's only one part of the whole work, and still the what is expected out of your work is the analysis, is the results, okay. Next is, how do we start learning doing research, okay. So as a first step, when you have some vague ideas, some keywords, some sample data to start your work, one good way to learn is replicating different papers, okay. So let's say you have read some very good papers that are of interest to you, you like them, okay. So one way is that see, whenever we try to do a dissertation, for example, people expect you to do something new in your work, okay. But to be frank, it is not easy to do something new in a short duration or even in a longer duration. So one way to reach this goal is that start with some good paper, read that paper, understand that paper, replicate that paper, maybe on the same data if it's available, what they have mentioned in the paper. Replicating a known published work is a very good way of learning things, learning ideas on the same data. So what all we see, what are the advantages of replicating a paper is, first thing is, since it is published, okay, and the technique is well known, you get some clear idea how to use that technique, in what context the technique has been used, okay. Then when we read new papers or related papers that are very interesting, novel, so we come to know about state of the art, what's currently happening in that area, what are some new developments that have taken place. If you read more than one paper, you also get a chance to do some kind of a comparison. For example, in paper 1 I read this, in paper 2 I read this, in paper 3 I read this, and then in your own mind or in your paper you do some kind of a comparison. In what way these papers are similar, in what ways these papers are different, what are the key important takeaways from the papers, and so on, okay. You are also making yourself aware of the possible data sets that these papers have used, okay, in their experiment. So some of the data sets might be easily available for by downloading or using some kind of repository. Some data sets may not be available, but that's fine. We can only work with the data that we have. Now, when we work on existing papers, or while replicating them, we also validate our existing idea. So we may have learned some concepts, and we may have seen its application in some paper. Until you validate that, it's difficult to convince ourselves. Okay, we have learned, but if there is a question, have you seen whether the technique works? We don't know. We have learned. So one way to validate our understanding is to implement what we have read in that paper. Finally, when you read several papers, maybe 2, 3, 4, 5, when you implement them one by one, you also see strength and weakness of each paper. You also realize strength and weakness of each paper. Okay. Finally, by comparing among these methods, between these methods, you do some kind of a comparative evaluation on different points, on different, let's say, parameters. Okay. And then you put on your own thoughts and comments. So what you found interesting in paper 1, what was the drawback in paper 2, what is the strength of paper 3, and that way you try to see in what way these works are related, in what way they are different, in what way they have strength and weakness. So write down these points as your own thoughts, as your own personal comment to the review of that paper. Okay, we will talk more about that, how you write your personal comments, but write your own thoughts. What did you learn from the paper? What is something that is rubbish in the paper? What is something which is not at all relevant in that paper? What is something that is the key selling point of the paper? Okay, so they will help us to know state of the art. They will help us to know what is the current data sets available for replicating the experiment. They will help us to validate our skills, whether our understanding of the topic is by far appropriate or it has some lackings. Moreover, they will also help us to understand strength and weakness of each model, each methods. Okay. Now, the small pathway to go for to reach a novel work begins by replicating a paper. So it is very important to state that a novel work cannot emerge in a couple of weeks or in a couple of months or even in a year. Okay. So these small steps that we take by reading a paper and implementing that paper helps us to reach that goal. So how does this happen? Okay. Every one of us is expected to do something new in the project, something new in the dissertation, something new in the thesis. But how do we come up with something new? That's the question, right? So it starts, the basic step starts by reading a paper and replicating it as it is, just by experimenting yourself. Think of replicating a paper as a tutorial. It may not be that easy to replicate always. Sometimes some details are omitted from the paper. So we have to understand them by our own intuition, right? So it's not as easy as a tutorial, but think of them as something that allows you to get in touch with the data, get in touch with the method that paper has described. Okay. Next, another important point, very important point is that once you have replicated a paper, okay, try using the same technique on another application. For example, you may have heard random forest is a classifier, very popular in machine learning. Okay. So given that we have understood what is random forest, now let's see how applicable it is in different domains, in, let's say, in biology, in market experiments, in space science. We want to see that the method what we have learned, how good or how applicable it is to our own domain. Okay. So even this is a research. If you are a person who has, for example, first time applied a method to your own data, then it's a new research, because techniques exist, but we don't know how far it is applicable to our domain. Until you show them practically with experiments, people may not believe that. Okay. Now, when you replicate a method on your own data, okay, try changing components of the method, try changing parameters of the method. Each model may have some parameters, inputs. Okay. try changing those parameters and see how does each parameter impact the model output. You can do like something like doing same experiment multiple times, okay, with slightly different settings, right. Now, gradually when you do this over a period of time, reading a paper, replicating a paper, working, trying to use the method on a different data sets, changing parameters, gradually you can think of incorporating something new in the method by improvising it, something new in the method by improvising it, such as trying to integrate two ideas, okay. So, let us say you know method A, you know method B, you know that method A has some strength, some weakness, method B has some strength which overcomes the weakness of method A, but again it has some weakness. If I integrate the two, maybe serially, one and then the other, rather than merging, I am serially implementing one above the other. Will it create an impact on the output? How does it create an impact? Will it improve my results? By what magnitude it will improve the results? Ask a question, do the experiment, check the results. Okay. So, this application of multiple methods on one data is called ensemble learning. It is a new technique that has been widely adopted. It is called ensemble learning. So, for example, for solving a problem, instead of using method A, I will use method A, B, C and take the best of all the three, and show that as my output. That is called ensemble learning. Okay. So, ensemble learning has now gained lot of importance, okay. And when we do these kind of experiments, such as incorporating new idea, small idea for small improvement of the model, or trying to use two models one above the other in an ensemble, this can possibly lead to a new work. So, new work always does not mean that we develop or invent something totally from zero. It can even be a small improvement. Small does not mean from 88.99 to 90, but small means, let us say there is a small 1% improvement, 2% improvement. So, depending on the application area, 1% can be really very important. For example, in medical systems, okay, where you want to diagnose whether the patient is COVID-19 infected or not. Even 1% improvement in AI based system is a huge gain, because that might save a person's life. But let us say in some systems 1% improvement may not have equivalent value. So, for example, I try to predict number of vehicles passing from a traffic junction. So, I predict 90 and you predict 190. It may matter, but not matter much, because only the traffic intensity will increase at the junction, which will ease out. But for some applications, this 1% improvement is also very important. Right. So, this can slowly possibly lead to new work. I am not guaranteeing saying that it will give you a new work, but possibly it will lead to a path that can give us a new work. Okay. Now, once you have a new thought process about integrating something, using two things parallelly, serially, making an ensemble, you can think of developing a prototype of the proposed method. Prototype. Okay. You can think of testing that. You can think of using several data sets to do experiments on that proposed method. Okay. These smaller steps eventually lead to a novel work. So, it is not that over a period of few months people come up with new work, but small experiments day to day on an cumulative manner can lead to a novel work. And of course, all of us are expected to show this work in our presentation during MTech thesis defense, MS thesis defense, or PhD thesis defense. So, gradually this is all a cumulative effort over a period of years that can potentially claimed to be a new work. Okay. Now, as because we have 5 people here who are already PhDs or already faculty, they may also share their experience. What are the parameters on which the theses are evaluated? So, we work 5 years and 6 years, 7 years sometimes, and submit our thesis expecting that everything will go go on as per our wishes, good, and we'll get a degree. So on what basis the external reviewers evaluate our work? Okay, this is not only relevant as a thesis review, but also on proposal review. I will talk about grant proposals later on which something similar is applied, something similar evaluation strategy is applied. What is the first part we look? First part we look is what is the technical quality of the work. Technically, the word definition of technical may vary from domain to domain, but in your own domain, what is the contribution, main theme, main idea behind your work? What is the quality of the work? Yes, sir, please.
Actually, depends on whether a student is MSc or a PhD.
Yes, yes, yes.
And the technicality, the significance, and all will be decided by a committee that we constitute at the institution level.
Yes, yes.
So we will decide, thesis, title, objectives, and all. So we will also meet once the student complete the process, and again evaluate. By the committee and also the institution heads. And then we will send it to
External expert.
So whatever the problem with novelty or the significance or importance will be taken care by the committee that we constitute within the institute.
Within the institute, yes.
So and it will be a less problem, headache for the external reviewer.
Yes.
So that way we will ease out
Yeah, we try to sort out this issue before even submitting, so that we don't get a sudden news of thesis rejection. But again, I completely agree with him. But even in some cases, I have seen that even with such efforts, there are some examiners who are really very tough, and they seem to reject such thesis. So one of my close colleague, who is already faculty in I won't name the university in Kerala, and he submitted his thesis at IIIT and was rejected. The thesis went to IIM Bangalore and was rejected, and he had to actually work one more year to bring into a shape. So even with all these precautions, what we do at our own level, sometimes if the examiner is tough enough and looks, he or she may look for something which is in his own or her own mind, that may not be there in the thesis, and the evaluation criteria is something pre-framed in their own mind which they want to look at. So sometimes gets rejected, but in most cases we hope that the results will be satisfactory with some minor comments. That is the ideal situation. Okay. So what are the things that people look for? May differ again from domain to domain. The quality of work. So quality of work from domain to domain, and some smaller questions to check are like, for example, does the material that is presented in the thesis make sense? Are the experiments that have been conducted, they are reasonable? Are the proposed methods, applications, algorithms clever and interesting? Does the student convey novel insights about the problem or about the method? Okay. Then examiners look at the significance of the work. So did the student choose an interesting real world problem or a toy problem? So in recent times, there are many problems in computer science and all, where people take a very small data and very small experiments and show it as a novel work, so which can sometimes be false. So because until the method has been extensively studied, you cannot claim anything, right? So reviewers, they look into these points. Are the work likely to be useful or have an impact on the society or impact on the science, knowledge of science? Then novelty of work, of course, is something that is everyone is bothered about. What is new in your work? What is new in your thesis? And this is a question everyone is asked in their defense. Okay. So what is novelty? Is this research applying a common technique to a well-studied problem, or the problem or method relatively unexplored? This is something that defines what is novelty of a thesis, novelty of a work. Okay. So we must have a solid discussion, a discussion section in our thesis or in our every section of the chapter. Okay. That summarizes the learnings from your experiments or your methods. What are the learnings? Okay. And Also, it should highlight how your work compares to the existing approaches, that is comparing through others' work via papers. For example, you can claim that I have got this result, which has also been shown to be in other papers published in by this in the year 2021-2019, which actually in some sense adds value to your work, that yes, your work is comparable to some highly cited published papers in journals. Okay. Okay, now we got some idea how to go about and how theses are evaluated. So based on this, we can now formulate some statements that will help us to go there. Okay. So again, be careful with too ambitious ideas. So it should definitely we should definitely see that it's in the work is within our domain reach, and for that look at these points. What are the points? Look at the feasibility of ideas, whether I talk practical or I talk something which is irrelevant, too much too much ambitious. Okay. What is the amount of expertise I have? What is the knowledge I have? Okay, suppose if I do not have knowledge about plants and I want to take up a research in plants, it will be illogical. So I may have a collaborator who is expert in that domain, and then I may try to integrate my knowledge with his knowledge, come up with a new something novel. Okay. So always look what is your acquired knowledge, and that assess yourself in that domain and see whether we are capable of doing that work. Okay. Whether the data are available. So data is very important. Without data, we may not even able to proceed. What is the interest in that subject? It is boring one or really very exciting to work in some challenging area, and so on. What is the significance of the work? How will it contribute to science? How will it contribute to humanity? How will it impact the market, and so on. Timeline, whether can I complete this work in the given 2 years, 3 years, 5 years. Okay. And do not take the findings that are presented in newspaper at face value. So always refer to some standard published journal papers or good conference papers which have citations where people cite that paper. Okay. So newspapers also report some new findings, but those are not properly articulated, so do not take them seriously. Okay. Now this is something which is very tedious, time taking, and everyone has to face that. So people say that go for literature review, and nowadays with everything online, we have thousands and millions of papers online by publishers. How to search that? How to search the relevant papers for our interest? Okay. So let's start with the basic premise that we iterated at the beginning. Purpose of research is to discover answers to questions through the application of scientific procedures. Okay. Now, why should we read paper? Why should we do literature review? They help us in many ways. Okay. For example, they help us to stay relevant and increase our knowledge, stay relevant in our area and increase our knowledge as a professional, as a practitioner, okay, or also as a academician. Okay. So to stay relevant or be up to date in our own domain, we must have a academic mindset. We must have academic mindset means keep learning, because things change so drastically, so fast, that if we do not keep a pace, we may be lost in our own domain and be outdated. Okay. So some technologies change very fast, so we have to keep pace with them, and the only way is to read some research papers in the domain in which we have interest. Okay. So it's not that once we finish the PhD we are done, and if you join academic job, for example, you have to read the papers throughout your career, because that is the only way to be updated and guide other students in your own domain. Okay. So it's natural for us or any person to pick up skills and habits which people have in our environment, right? So therefore, most scholars who do masters, PhD, etc., they look at their peers, they look at the people who are doing PhD in different stages of their career, and they get the instinct of digesting contents of research papers. I mean, it becomes a culture. Read a research paper, understand and digest it. Read many research papers, understand and digest. It becomes a culture. Everyone talks about research paper. So your entire peer environment is such that it motivates people in academic or in doing scholarly research to read papers and understand them and digest them. Okay. So the question now is, how do we gain the required skills to search, read and understand contents of a research paper? Given that we have millions and millions of paper available online in Google Scholar, ResearchGate, Elsevier, IEEE, and it gets added every month, every year. So given that huge repository, how to search, read and understand relevant materials? This and the following discussion will continue for another 10 minutes. Okay. Okay. So now I am not talking about any particular journal, publisher, etc., but in general, how should we go about searching materials, right? So first thing is, assemble or collect all the resources that are relevant to you. Okay. What can be the example of such resources? Examples can be research papers, medium articles, blogs written by other people. Many people like writing blogs. There are so many videos in YouTube, etc., and NPTEL and Coursera. Okay. GitHub is a nice place where you get codes written by other people, okay, and so on. So a quick Google search of the topic of your interest will give link to all these videos, GitHub and so on. Okay. Will give link to all these that is related to your subject domain. So in the beginning, as an initial step, what we do is collate all these relevant information irrespective of the source. They can be YouTube videos, implementation document, research papers, GitHub repository, data repository and so on. Okay. So in this stage, we don't even think about a number of papers we should read, etc. Irrespective of that, we want to just create a list of resources that will be relevant to us. Okay. Now in this step, what we will do is do a deep dive of the resource that we see to be very relevant to us, okay. So it is also very important to keep track of the understanding of each shortlisted resources. It is also very important to keep track of the understanding, how much do we understand. So for example, there are lots of Coursera courses online, okay. So if you take up a course, how much of that are you able to understand? Are you bogged down by some mathematical description and don't want to continue, or you want to bog down because the application they have discussed is not directly relevant to you? So we want to track how much do we have progressed, okay. So as I said, these are some different sources of information, including research papers, online web links, YouTube videos, online copies of thesis in libraries, blogs, tutorials, GitHubs, implementation documents, online video demonstration, anything that is relevant to us, that is relevant to our topic. Okay. So the next slide is not very general, but I request you to only take away message from this slide is that look for state of the art papers, recently published papers, and it can be any journal depending on your domain. Okay. For example, IEEE is a popular publisher and society for technical areas where they have IEEE transactions as very good journal papers. IEEE letters. ACM is again a society for computing which has very good journals. Elsevier is a very popular publisher which has which publishes in all different domains. Taylor and Francis is again a very published, very noted publisher. Okay. So refer to any relevant material that shows state of the art in your domain. What's happening currently? State of the art means what's the current status as of now, what is something best in the market. Okay. And also do make it a point to refer to the relevant references in those published papers. So every paper has a reference section which is also equally important. They give link to other important materials. This section, references section, appear after conclusion and acknowledgements. Okay. Now, after going through all these resources, abundant number of resources, and after you have extracted some important information, we will create a reference table. We will create a reference table, okay, that will look something I will show in the next slide, that is this slide. Okay, this is my reference table and it shows my understanding level. It shows my understanding level. Okay. Please also wanted to just caution you that do not treat each paper published of to be of very high importance value. There are very large number of conferences that are locally held, may not give you additional value to your knowledge. Also, there are many journals that may not be very prestigious and maybe local journals where they do not publish high quality research, but replication of some existing research. So, try to identify those journals and keep it out of your database. Okay. Create a table something like this. So, I have a resources, I found out 10 papers, online links, YouTube video, thesis, blog, tutorial, etc. And what is my level of understanding? 10 to 20, some papers are very tough to understand, okay, especially in that those have more mathematics. You may find it very difficult to understand. If they have more of statistics, you may not find it easy to grasp in first go. So, what is the understanding level? Maybe you can divide them into smaller bins and give them a relevance, like something like a rating 1 to 10, how relevant this paper is based on my understanding of that paper. Okay. Then at the first iteration, try to see that you read almost 10 to 20% of the contents of each paper, or listen to videos, or read the blogs and so on. This will ensure that you have been exposed to enough of introductory content. If you read or listen to 10 to 20% of the content of videos, papers, blogs, it will ensure that you have been exposed to enough of introductory content relevant to your topic, okay, within the resources that you have, and you will be able to realize its relevance accurately, whether the problem statement that I am planning to work, how relevant it is, how important it is. Okay. Then with more relevant, for the more relevant papers which are directly from some journals that is in your field, it is expected that you now progress to a higher level of understanding. So, we may have to further read those papers in more detail. Okay. Eventually, over a period of time, you will have identified some appropriate resource, saying that, oh, these 3 papers are the really ones which have enhanced my knowledge in this domain. Okay. Over a period of time, you would have identified some resource that will the contents of which you must understand fully. Okay. So, this table should now look something like this. Paper 1, 80% I have understood, but relevance, in terms of relevance, it has a 7 score. Paper 2, 8 score. Online link 1 is very important, I have given 9 score. Okay. And then from this you derive a final reference list. So, these are my most relevant source of information for the topic of interest with some high scores, and anybody who wants to pick up this area for research must read these papers or listen to videos and links and so on. So, this nobody will give you, this is your own work will give you this. Nobody can give you ready made. You have to derive this table on your own by reading and giving stipulated relevance marks or points to each source. This is your earning. This is your earning. Nobody can earn it for you and give it to you. This is only your work, only your habit of reading can over a period of time fetch up to this point. Okay. So, I assume that we got some relevant papers, okay, and we have a list of resources which we can think of reading in future. Okay. Now, question is how to read a paper. So, some papers are very lengthy, 20-30 pages, some are short papers, 4-5 pages, right. So what is the strategy to read a paper, and how do we understand the paper? Okay, so there is a clue, we must have a strategy to do this, or else you know what will happen, months and months you will be reading only paper and time will pass on. Okay, so how to make a strategy to get the most out of paper by spending lesser time. Okay, following this, now we will discuss on the how to read a paper. Fine. So let's first categorize the papers. Okay, categorize the papers. So I have categorized into 5 themes. First one is the review paper, also called overview paper, also called survey paper. Survey papers are generally written by experts who have been in that area domain for 10, 15, 20 years, and they know the subject very well. So they are something like who can write compare methods, compare what happened 20 years back, what's happening now. They write a review kind of thing. Okay. Other types of paper include improvement paper. So they will talk about some method which was discussed 10 years back, and they have now improved that method, and after 10 years they are getting better results. Third type of paper is new method, which will altogether talk about new method, new algorithm, new models which other people have never tried. Okay. Fourth is state of the art paper. State of the art paper are those which are completely new to academicians or researchers. People have not even heard about. For example, you all have heard about the word machine learning, deep learning currently. Okay, there is a new term called transfer learning. Okay, and then there are new terms like transformer. Transformer is not related to electric supply. It's a classification technique, transformer. Okay, transformer has been developed by Facebook AI, and this is state of the art. Beyond that, we have no other techniques as of now. Next year it will come. Some Google or somebody from MIT, Stanford may come up with something new. As of now, that is the state of the art. So every domain will have a state of the art, the best in their field. Some papers are categorized as state of the art. Last one is the application paper. Take a method, take a data, apply it, get the results, show the usefulness, give the accuracy, and conclude the paper. Okay. So broadly, all papers will fall in these 5 themes. So to begin with, it is good to start with review papers. You will get an overview, overall idea, what all things are there, somebody written by somebody who is expert. Okay. Let me show you examples of each of these papers. So these may not directly be relevant to you. Don't worry about the terms used in the paper. These are taken from computer science conferences journals, but something similar I will expect even in your domain. Okay. See the paper title, a review on deep learning techniques applied to semantic segmentation. Okay. What is segmentation? Segmentation means extraction. So look at the line which I have underlined with blue color. This paper provides a review on deep learning methods for semantic segmentation applied to various application areas. So when I say various application area, it can any area, it can be your area and so on, but more important is use of deep learning technique for any application area. Okay. On top of that, it's a review, means all these authors who are there may have been working in this area for last 5-10 years, and they know what changed over a period of time. They have written a review and how this technique can be applied in different areas. Okay. This is a review paper. This is again an example of an overview paper. See the title, it was published in IEEE Transactions. It's a very good journal, September 2019. Okay. Title is Deep Learning for Hyperspectral Image Classification and Overview. Overview, something similar to survey. So look at the line there, in that left column. This survey paper presents a systematic review of deep learning methods and compares several strategies for this topic. Okay. So, you got an idea what is survey overview, they will do some comparison, they will discuss what happened in the last 10, 15, 20 years, how did the methods, problems, solutions evolved, and with their experience they write this paper. Okay. Now, see, this paper is written by people from Facebook AI research, in short they call it FAIR, FAIR. So, this paper talks about learning to refine object segments. This is a improvement paper. There is a method, for example, Bayesian classifier. Bayesian classifier. Many of you may have heard about Bayesian theory, Bayesian classifier. It is a statistical classifier to classify objects based on the membership. Okay. So, if you improve the Bayesian classifier, this is the kind of paper you can expect, improvement paper. Okay. See, look at the lines here in the abstract. In this work, we propose to augment feed-forward nets for object segmentation with a novel top-down refinement approach. So, now because they have done an improvement, they call it novel, new, but it is not new, it is on an existing method, they have improved, done some improvisation. This is the improvement paper. Look at this paper. This paper is written by some Chinese. So, look at the title, heterogeneous transfer learning for this data classification based on convolutional neural network. Okay. Keyword here is heterogeneous transfer learning. Heterogeneous transfer learning is a new technique people have developed. So, look at the abstract, look at the blue line. In this article, heterogeneous transfer learning for HSI classification is proposed. They are proposing it, that this is a new technique I have designed. Okay. So, this is a new paper, new model, new method or new algorithm in computer science, new method altogether. Okay. This is state of the art paper, again written by people from Facebook AI. What they have done, end to end object detection with transformers is something. Look at the first line. We present a new method that views object detection as a direct set prediction problem. New method. So, this is state of the art. So, right now when this paper was published, this was the latest method available for object detection. Okay. What can be, give me an example of object detection. Object, you know, everything is, here is object, table, chair, seats, bottle, object detection. No, I mean, if you can tell me an application where you want to detect objects. Satellite data definitely. From satellite data you detect houses, you detect rivers and so on. Any other possible application? Camera. Autonomous vehicle. So, in autonomous car, you know that there is no driver, right? So, the car should automatically detect all the cars in front, in the sides with sensors, and accordingly change the lanes. So, we should have a detection and segmentation software in that. Okay. The software should be able to take picture of the signal, and if it is red, it should stop immediately. Autonomous cars. So, this has huge application. Okay. One very relevant application I can tell you. If you are a user of Facebook, okay, all of you will be definitely, most of you will be a user. So, still some time back there was an application where it will detect people's face and suggest that this is your friend. How does it do that? Even if you have met that person long back in school, in college, somewhere, it will connect that person to you and highlight the face and say this person is in your friends not list, but in your known community. How does it do? How will Facebook know who was your friend in school? What strategy, what algorithm they have built? So, I will tell you what they do. See, first thing is they deploy object detection. They will extract the face from all the pictures. Okay. Then they develop a graph. So, they will connect you with all your friends. Okay. Then it will connect your friends to their friends. Okay. Then it will connect their friends to their friends. Finally, that person who is a suggestion to you as a friend will be a connection. So, they will make a link, graph, like a graph paper. Okay, here this to this, this to this, this to this, finally you see that this person is connected. So it is suggesting that this person can also be your friend, because all these people are in the same graph. So using this graph methodology, they detect your possible friends, they want to increase your friend list. Okay, so this is how they do. So it's very interesting, and they have deployed it in real time, and you also feel surprised. Oh yeah, she is my friend. I saw in school, I saw in college, I met in a conference, right? So this is how they do that. They use a graphical model to explore all connections between each one and among your friends and among their friends and so on, and they are then able to link you to the new person. So this has direct, see, that's why this paper is written by Facebook AI team, where one of them might be using this technique for connecting friends. So this is state of the art paper. Look at this, this is a publisher called MDPI, and in the journal Remote Sensing, the title is Deep TEC, Deep Transfer Learning with Ensemble Classifier for Road Extraction from UAV. UAV is drone. UAV imagery means drone imagery. So what they are doing, from a drone imagery, they are extracting roads. Okay, so see that whatever is the technique, this deep transfer learning, they are applying it for some purpose. What is the purpose? Road extraction. Okay, so in this, see, the paper focuses on a novel method which consists of deep TEC, deep transfer learning with ensemble classifier, for road extraction using UAV imagery. So technique is not there, technique somebody else has developed, but they have first time applied it for road extraction. So it becomes a novel work. Now I can do something, I will take their technique, apply it for crop detection. It will become a new work in agriculture. Or I can use it for tree discrimination and extract similar trees from the whole image, from a drone image. That will become a new work. So I am not developing anything, I am taking this deep TEC, deep transfer learning, and using it for a new purpose. Like road extraction, I will use it for plant extraction, or agriculture crops extraction, water bodies extraction, lake extraction, and so on. If you are in defense, you might attempt extracting bunkers or tanks or shelters at the border. So this is what people do, like there is a conflict going on at the border between India and China. So if there is any, so they keep taking photographs of the border. If there is any new establishment, like new homes, new tankers, they will detect it. That is using these kind of methods. Road extraction, so it will become bunker extraction, shelter extraction, tank extraction. They will see, oh yes, first day of December, there were 10 tanks, today 500 tanks. Something is going to happen. They will give an alert. So until we adopt such technology, you will not be able to know what's happening on the other side of the border. So we have to be equally prepared, and only way to know is through satellite data. So apply these techniques on satellite data, extract what is happening, and update our military defense. So it has huge applications. Okay. So we saw some different types of papers. Now the question is how to read the papers. They are all of different types. Okay. So reading for the purpose of understanding. One is reading and sleeping. Okay, take the paper when you want to sleep, read half page and nice sleep you will get, right? But reading for the purpose of understanding is different. Okay, so we have some popular books, which we don't like. Anytime you want to sleep, take that book, only one page read and throw it and sleep. But here the point is we have to not only read, understand also, right? So reading the paper, if you want to understand, is not possible by reading it once or going through it like a scanner. If you scan it once, it will not happen. Okay. So also very important is, if you think I will very dedicated today, let me sit at 8 AM and I will finish from first word to last word. Let it be 1 PM, I will not move. That is also not recommended. So if you want to read from the first word to the last word in one sitting, okay, it is not the best way to read a paper. What you should do? You should be prepared to read a paper at least 3 times. at least 3 times, okay, that will give you a good understanding of its content. So, how do we approach reading 3 times? In the first iteration, just read the title and abstract, that we can do. Sit half an hour, you will finish it. Half an hour is also too much, 20 minutes. 20 minutes reading title and abstract, first scan done. Second, in the second pass, read the introduction conclusion section. So, not too much of work on the brain, we can do it 40 minutes, 45 minutes, introduction and okay. So, what do these sections tell you, introduction and conclusion? They will give you a clear and concise information of the contents of the paper, okay, and summary of important findings of the paper. The introduction section, conclusion section will give you clear and concise information about contents of the paper and findings of the paper. Okay. So, these two sections, the introduction and conclusion, so they do not have, they are not very lengthy, mostly they will be 1 page, 1.5 page, etc., or 2 pages maximum, and they will only have very relevant information. So, it's not that you are reading too much to gain something, only a few lines. They will be to the up to the point, concise and clear. So, they will make your understanding of the subject better. Okay. These two sections are also important because they will help you to further get into the other sections. If you know the introduction, and you will be able to understand the methods, results, etc. So, therefore, we cannot skip them. Okay. 2 passes are over. Third pass. Third pass involves reading the whole sections within the paper, but skipping what? Complicated mathematical equation, which everyone is scared of. Just leave them, okay, or any technique formulation which is too difficult, skip them, do not worry about it. Read all the text part, understand it. Okay. So, any term, equations, expressions, mathematics which you do not find convenient, leave them, skip them. Okay. Finally, one last pass, fourth pass, where you will focus on understanding those equations which you had skipped in the third pass. See, trying to learn one topic at a time is easy, but if we say that read all 20 pages, understand from first word to last word, it becomes too difficult. So, if you sit on with a intention only to learn some mathematical expression in the paper, it can be acceptable. So, you can spend some time in the fourth pass, get the whole paper cleared. Okay. And after you have done the fourth pass, it is very important to take structured notes, because if you read today, tomorrow we might forget, right. So, we must take some structured notes, not some writing some paper, throw it in the dustbin or keep it under the bed, not like that. Keep a copy or some register somewhere, put a structured notes. What to write in that notes? In that notes, summarize the following: techniques, key discoveries and findings within the paper in your own words. Do not copy the same thing as it is, then that is not our learning, right. So, in your own words, describe the technique, key discoveries and findings. Okay. So, once you have read the paper, please do not do this in a notebook. Okay. Please write in a legible way, so that we can, anybody else can read after a few weeks or years and so on. Okay. So, people have the habit of making this kind of notes, connecting some box here and there, but tomorrow it will be useless. Nobody will be able to understand what you have written. So, we must write a structured review of the paper. Okay. So, how to write a review? We have to be very systematic. Okay. How to go? By the time you read your third, fourth, fifth paper, it is 100% sure we forget what is there in the first paper, right. So, maintain a table, a review table, and write these contents. Okay. Make the table simple. So, divide the table into some columns. Let us say take Excel sheet, Microsoft Excel. Okay. It has already inbuilt columns and rows. In each column, first column put title of the paper, year, name of the journal, who all wrote the paper. If there are too many authors, just say first author et al. Okay. And that is it. So, first column, title of the paper, year, name of the journal, first author, that is it. Second column, what is the goal / aim, objective of the paper. that will be generally found in the at the end of introduction. Okay. Third column, whatever new you have learned, such as new methods or techniques or whatever methods techniques they have used, you can list them. You can list a method, for example, Gaussian mixture model or ANOVA, whatever method they have used. Okay. Fourth column, only write about the data set they have used. So, they may have collected, they may have simulated, they may have downloaded, they may have got from some friend. So, whatever they write, you just note it down. Okay. Fifth column, any important significant result and findings along with accuracy values. So, if they are doing some statistical analysis, they would report accuracy, note down what accuracy they have got. Okay. And what metrics they have used, because different papers use different metrics. Some people use, for example, RMSE, some people will use MSE, some people will use MAE, mean absolute error, mean squared error, root mean square error. So, what metrics they have used. Okay. Then column 6, limitation of the study, which is also generally given at the end of discussion section, and scope for future work. What more can be done in that work. Last column, your personal comments on the paper. So, you can highlight drawbacks of the paper, what you observed, what is the learning from that paper, what is the view on the paper, your own comments, your own thoughts. Okay. Whether it is relevant to you, not at all relevant to you. So, you can make a note of this in the last column. So, do this for every paper. Okay. The columns 1 to 7 which you see here, they are very important because they will help you to find the research gap for you to address, that you will take up as a dissertation. Okay. Now, it is true that when you read in depth any paper, it is very time consuming and also sometimes very boring. Okay. So, in cases when you have lots of paper to read. Okay. So, have patience, do not rush, read a paper when you feel fresh, because the overall idea is to understand them. Okay. And ask some questions to yourself. For example, describe what the authors in the paper aim to accomplish, what do the authors want to show in the paper. Okay. If a new method, approach, technique have been proposed, okay, what are the key elements of the newly proposed method? Okay. So, this is the question that you are asking yourself after reading a paper. Okay. What contents within the paper are useful to you? Many of them may not be useful. Okay. What other references do you want to follow? So, there are papers in the reference section which may also be equally important, equally attracting to us. So, we might look 1 or 2, 3 of them and try to read those papers. Okay. So, we have to have a positive and creative thinking after reading a paper. What are the good ideas in the paper that we have came across? Okay. Do these ideas have any other application in your domain or directly relevant to your data? We can think, right. Can they be generalized further? So, if a model has been developed, can I adopt it for from one domain to other domain, one application to other application? Like I showed you that object detection. I told it can be used in autonomous cars, it can be used for satellite imagery, in defense and so on. It has wider applicability. Are there possible improvements that you can make, and are there any practical differences? Okay. If we are going to start doing research from this paper, what would be the next thing you should do? Let us say this paper is my starting point. I would like to start day 1, read this paper, start your research. What would be the next thing you should do after reading that paper? Think about this. This cannot be generalized. So, this will be your own thought in discussion with your supervisor or professor. So, you can discuss and think, okay, what should be the next step I should do? I have read this paper, I have learned these things. How to go about next? What next? Okay. Okay. If possible, if you have read 3, 4, 5, 20 papers, try comparing them. In what way they are? Why did all these papers appear in the same journal? Why did this paper appear in the same volume, same issue? there may be some relevance. So can we compare them? Is it possible to compare, or they have totally different school of thoughts? They cannot be compared. We can decide these things. Okay. Summarizing a paper again is one way to determine what is the scientific contribution of this paper. If you summarize it, you will be able to know, okay, this paper has contributed a new method which people did not know, for example. Okay. Also ask a question, are the ideas really novel, what is described in the paper, or have they appeared before? So one technique, for example, talking about some Gaussian distribution can appear in several papers. So you may be able to recollect, oh, this distribution they had talked in paper number 2, paper number 4 also. So I think this is important, that's why they keep discussing it every time, data distribution. Then scientific contribution that you are thinking about by summarizing the paper can take some of these forms. Some paper offers new ideas altogether. Other implements ideas. Other papers they implements idea as application and show that these techniques actually work. This method actually works. Okay. So one is, the first one is a development, new idea. Second one is the application of that new idea. Okay. And some papers they bring previous ideas together and unite them under a novel framework. This is the easiest one. So I will give you I will tell you about one story. Okay, so I had joined IIM Indore as a faculty before this, and the admission is taken through CAT exam. CAT exam qualifiers they appear for the group discussion and interview. Followed by that, they are selected in all the IIMs. So in one batch, they generally keep 5 to 6 people for group discussion. They will give a point, some topic, and ask people to discuss. Okay. Many times it happens that you have not even heard of that topic. Forget about discussing about that topic. You have not even heard about any term in that. What to discuss then? Okay. So I saw one candidate in that group. Okay. So I could make out from his face that he has not even heard about this topic. So forget about giving inputs. What he did is he noted down. He looked at everyone's face and he noted down what everybody is saying. Okay. And then once the discussion was about to be over, nobody had any point. He took his paper and say, I would like to summarize. And he says, A told B, A told this, B told this, C told this, and the learning is, key message is that, or takeaway point is that this is the fact. He gave his opinion. He was selected. So that is what is in this. They have no idea, take all ideas from different papers, unite them to a new framework. You come up with a new idea altogether. So this is again new way to discover something. Okay. This is very interesting slide. So you will now ask, how many papers should I read in my degree program, etc. Okay. So you start by looking at papers that have been published in the last 5 to 7 years to 10 years, not more than that generally. Depending upon the subject, it can also change. This is not a strict rule, but things which change, where changes happen very rapidly, things will change drastically in 10 years. So this could be a time frame, but you can decide. An understanding of 10 to 20 papers will showcase a basic understanding of the subject matter. Especially for MTech or master's level, 10 to 20 papers will be sufficient to understand the concepts. Okay, 500 to 150 to 100 papers will primarily provide you with a very good understanding of the domain. This is typically also possible for all masters and PhD level. Okay, but the point is, the more papers you read, the more control you have over the subject. Okay, I may give a number to the number of papers you should read, but you will realize at the end of your degree that you have read more than what I have told. And for a master's thesis, you might have read almost 75 to 100 papers. For PhD, you might have read 200 papers over a period of 5 years. You will realize that lately when you start writing your bibliography, So, it is important that you use some software to maintain the details of the paper that you read. So, there is one session in last day where you will learn how to keep track of all the papers that you have read. Okay. So, advantage of that is when you are writing references in your thesis, we do not have to type it, just go to export and Word format, it will automatically arrange everything, give you another document with all references, copy paste in your thesis. So, that is the kind of a management software for bibliography. What is that called? No, LaTeX is that already you people know that EndNote, and there are so many, right? EndNote, yeah, EndNote, yeah. Okay. How frequently should I read a paper? Yeah, this is last slide. After that we can read. How frequently should I read a paper? So, it is very good if you read one paper every week, very nice, nothing better than this. Worst case, read one paper at least in 15 days. Okay. And do not get bogged down with equations. So, do not throw the paper if there are some equations, because they are actually intended to improve our concepts and understanding and both logics. The more and more you read, you get better and faster. So, first paper you might struggle, but your 10th paper will be very easy to read and understand, because you get the habit. Okay. So, one way to know when the new issue has been released is subscribe to some journals, and they will so they have a message like sign up for alerts. So, whenever new issue is released every month, you will get an email, new issue has been released, these are the papers published in this issue. Many journals nowadays are open access, so we do not even have to subscribe or pay anything, we can download right away and read them.